Okay, so in the last class, we were talking about different types of energies, and different students came up and they presented on different energies, and they did a fabulous job. So today we are going to talk about the sources of energy that we use in daily lives, you know, at an industrial level as well as at domestic level. So this is page 14 in my book. I don't know what the page number is in the new edition, but this is the page that I'm following: renewable sources of energy. And so these are the energies we will discuss. Okay, so I consulted your scheme of studies and these pages are included. Okay, but before I do that, just a little explanation on electromagnetic radiation, because I remember we did not talk enough on electromagnetic radiation. Now, what is electromagnetic radiation? I hope we did discuss that radiation is that source of energy that does not require a medium to travel. And so it can travel through vacuum because it does not require any molecules or atoms vibration for the transmission of energy, right? But what is it? Okay, and then we also appreciated the fact that sunlight is an example of electromagnetic radiation, and that enables it to travel through the vacuum before it hits the surface of Earth, right? Now what happens? Now, electromagnetic radiation is energy that originates from the atoms. How come? Just a brief explanation that if, for example, this is the atom, okay, for example, this is the lithium atom, right? And we have done the atomic structure in chemistry. This is the innermost shell with the 2 electrons, and then this is the second shell. And we're talking about lithium, and lithium has a proton number of 3 and 3 electrons, right? So I will take this easy, simple atom to explain you what electromagnetic radiation is. Now, if this atom is excited, it can be excited by light or heat or one of these factors. And when this atom gets excited, what happens is that one of these atoms jumps onto the higher energy level. And remember, I also discussed that the electrons in the innermost energy level are the ones which have the least energy, and therefore they cannot resist that electrostatic pull, which is being exerted by the positively charged protons, right? So now when this atom gets excited, this one of these electrons, or maybe both, or maybe one of them, gets excited, and they have enough energy to then jump on to the higher energy level, right? Now, if for any reason this atom loses energy or loses this excitement, and another thing that that for an atom to be stable, there have to be 2 electrons in the innermost shell, because that is the stable number of electrons in the innermost shell. So this state is unstable. This state in which the atom has only 1 electron in its innermost shell and 2 electrons in the second shell is unstable. So the atom would not stay in this state for very long. It would not want to stay in this way for very long. So as soon as it gets out of that excitement, or when it loses energy for any reason, this electron jumps back into its original position and jumps back into its into the lower energy level, and in doing so it releases energy. And that energy is what we call electromagnetic radiation. Okay, don't have to go into too many details of it, but knowing this much will be helpful, because I don't want you to just blindly ratify and learn. So understand what's happening in electromagnetic radiation. The electrons are, getting excited, jumping onto higher energy levels. And when they jump back to their original level, the energy released is called electromagnetic energy or radiation, right? So once we have understood it, so this is the process which is going on inside the sun. Okay, inside the sun, why is sun such a great source of energy for the whole planet? It's not exactly this process, Remember, Sidra explained us nuclear energy in my previous class, if you remember. And she was talking about, you know, the structure of nucleus, because so many positively charged protons are confined in such a small space. So because they are all positively charged, they must be repelling each other, right? Because like charges repel each other normally. So when this arrangement of protons is disturbed due to any reason, for example, bombardment of the nucleus with a subatomic particle such as a neutron, the arrangement of these protons is disturbed, and many of these protons and neutrons are released in the process, and a big amount of energy is released, which is called nuclear energy, right? And then Sidra also mentioned that when this process takes place gradually, the same energy is released in a controlled manner, gradually or slowly, and we can use that energy in constructive ways and positive ways. And if it is uncontrolled, there is a big explosion and destruction. So that's so in nuclear power plants, the same energy is released in a controlled manner, right? So that was a recap. Okay, now let's get back to renewable sources of energy. Now, what are renewable sources of energy? We know the meaning of the word renewable is that if we run out of these energies, they can always be refilled. They can always be renewed. That's what we mean. And how will we compare this renewable source of energy with non-renewable sources of energy? Non-renewable sources of energy, as the name suggests, is a source of energy which, if runs out, there is no way that we can refill our stores. We cannot refill or renew those energies. And the examples of non-renewable sources of energies are, did anybody read? Did anybody take the time out to read before the class? And if there is somebody like that, can that person suggest a few examples of non-renewable sources of energy? Yes. When the electron gets more energy from the last shell, then what happens? Okay. Subatomic particles are particles within the nucleus or within the atom, you know, Manal Ahmad. Subatomic particles meaning particles within the atom. Okay, that's what subatomic means. And Javeria, I did not get your question. If what you're trying to ask is that if after the electron jumps onto the higher energy level, if we keep exciting it, will the electron jump further to a higher levels? It might, okay? Okay, so yes, she's Imam, is that right? Is that your original name? Please use your original names. So yes, you are right. Coal and oil, they are examples of non-renewable sources of energy. So good job. Aisha, coal, Atika, coal, yes, okay. Coal, oil, and natural gas. Coal, oil, and natural gas. And from where do we get them? What is the source? Yes. What does Li mean? Oh, that's a symbol for lithium. So when I was explaining you electromagnetic radiation, I took lithium atom as an example. Okay. So what is the source for oil, natural gas, and coal, which are the non-renewable energy resources? Yes, Manal Ahmar, very good. Fossil fuels are the source. Good job. Yes, fossil fuels are the source. Nuclear energy is not the source, no. Nuclear energy, it is not non-renewable, is it? Wait, I think it is non-renewable, okay, but I'm not sure. Maybe it is partly renewable and, you know, partly non-renewable, but I need to check on that. Okay. Okay, so yeah, the source is fossil fuels. Now, another question, what are fossil fuels? So fossil fuels, just a quick definition of fossil fuels. They're just, you know, decaying organic material. Organic meaning materials that make the living material. Living material meaning material that has life, such as our bodies, animals' bodies, insects' bodies, plants' bodies, right? All of these living things and their body material, the material that their body is made up of, that's called living material and organic. So all that organic materials originating from plants or animals that have died millions and millions of years ago, and under the pressure, constant pressure and heat over millions of years, they convert into oil and gas. Okay, so fossil fuels are those compressed and pressurized, and you can say, compressed organic material that is the source of energy. Okay, so this fossil fuel, this is non-renewable. We don't have an endless supply of this. Okay, and your book mentions that the rate at which US and Europe are using these non-renewable sources of energy, if that continues, we will run out of all fossil fuels within the next 4 years. That's what your book says. Okay. Right. So yeah, and this book was written 4 years ago. That's right. Okay. Oh, if the whole world uses oil at the rate it is used in America and Europe, our oil supplies would end in about 4 years. They are non-renewable. That's what your book says. So yeah, so that's what makes them non-renewable. But the problem with this non-renewable source of energy, first problem is that we will run out of them, and so we won't have an alternative. Second is that they also produce a lot of pollution, a lot of gases. Number one is carbon dioxide. And these gases are harmful for our environment. They are harmful for the plants, animals, and us. They affect our health negatively, and they also cause global warming. Global warming meaning that they raise the average temperatures of the world, right? How does that happen and all? I'm not going to go into the details of global warming and all of that, but just understand that those are the harmful effects. We will go into those details, but not right now. Okay, now those were the non-renewable sources of energy. Now let's compare them with the renewable sources of energy. So the whole world is spending a lot of time and money on trying to get control over these renewable sources of energy. Why? Because first of all, they're renewable, so we are not afraid of running out of them. Secondly, they produce less pollution. They are cleaner for the environment, right? So those are the 2 plus points because of which we are spending so much time and money on these renewable sources of energy. Number one is solar energy. Solar, as the name suggests, coming from the sun. Now, I have talked about the sun. What's going on inside the sun? Nuclear energy. Nuclear energy, I told you, within the nucleus we have protons, and they are all similarly charged, and so they tend to repel each other, but they are forced to be in that small space of the nucleus. And then when a subatomic particle bombards it somehow, that just like a spring, it gets a chance, it gives that chance to the protons to move away from each other. And in doing so, a lot of energy is released, which is nuclear energy. And so this is exactly what happens inside the sun. Okay, there's a lot of nuclei undergoing all of this nuclear reactions, and they produce a lot of energy. And that is that is nuclear energy getting converted into electromagnetic radiation. That electromagnetic radiation then passes through the vacuum and hits the surface. Who is this co-admin security? Oh, okay. Yeah, because I don't want anybody with the fake name, okay? Just want to make sure. Okay. So how do we make use of this solar energy? The problem with all these renewable sources of energy is that, the problem with them is that, they're not energy dense. They're not efficient. What do I mean by that? Like, if you have a big mass, a big area, let's say, okay, how should I explain? Like, if you have a big container, you have lots and lots of something, but it has less energy. And the reason why using non-renewable sources of energy. We are still using non-renewable sources of energies because they are very efficient and they're very energy dense. From 1 liter of petrol, we can run the car for so long. Now, if you're using solar energy, or if you're using, you know, some other energy, that is not possible. To get the same energy as that 1 liter of petrol, we will have to have lots and lots of solar panels. So one solar panel, one big solar panel that would be, you know, larger than, you know, my table maybe, will run a pedestal fan for maybe 2 hours, 3 hours, and that's that. And only a pedestal fan, that's it. So the problem with all these renewable sources of energy that I'm going to discuss with you is that they are not energy dense. They are not efficient, meaning we have to capture a lot and we get less in return. We have to put a lot of input, but what we get is less, as compared to the non-renewable sources of energy, which give us greater energy per unit volume or per unit kg of mass or per unit gram of mass, whatever unit you want to use. So, okay, the instruments that we use to capture the solar energy are solar panels. Now, I will just in a moment show you pictures of solar panels. We have solar panels at the roofs of houses that capture the solar energy, and that solar energy is converted into electricity. And then we have solar cells. Many of you might have used solar calculators. And so if you have a solar calculator, I don't have one, but for those of you who might have a solar calculator, you will see a small solar panel at the top of the screen. Okay, that panel receives the light. I mean, it traps the energy from the light that's falling on it. Yes. And then it has the capacity to turn that solar energy into electricity, right? So that's an example of a solar cell. Okay, and then we have spaceships running with the help of solar cells. That's cool. And satellites running with solar cells. And then we have solar thermal towers. And now I'll share my screen and I will show you the solar panels and also the solar thermal towers. Yes, okay, okay. Keep it here, good job. Okay, so this is a solar panel. Can you see, this is a roof of a house. So can you see how big the solar panel is? But the problem again is, you know, even after having such a big solar panel at the top of your roof, it does not meet the energy, you know, it does not meet the energy requirements completely. You know, okay, they have limitation. Number one limitation is that you have the energy for as long as the sun is there. If for any reason it's cloudy, then you have a problem. If, you know, at night, if it's nighttime or if it's evening, then, you know, your solar panel and all of that will not work. You won't get the electricity. So those are the drawbacks that have limited us from relying on solar energy completely. But yes, they are helpful. It's better than nothing, especially, you know, in countries like Pakistan. Okay, then solar thermal towers. Now, what is this solar thermal towers? Can you see this big tower? This is, by the way, one of the biggest solar thermal towers of the world in Dubai. Okay, and you can see this tower is surrounded by these circles of mirrors. Can you see? Now, these mirrors are reflecting the sunlight which is falling on them onto the top of the tower. Can you see the shiny part, the shiny top part of the tower? And then there's fluid circulating within this shiny part of the tower, which is getting warmed up by this hot part. And so that warm water is then used, you know, to move the turbines or, you know, the generators. And, you know, you don't have to go into the workings of this thermal tower, but just understand that, you know, this tower is surrounded by mirrors and it is converting that sunlight or solar energy into electrical energy. And these mirrors are concentrating all that sunlight so that all that sunlight falls on that, you know, shiny part of the tower. Okay. And so that was all regarding the solar energy. Okay. Okay. Then let's talk about, okay. Yeah, and this is the solar panel in a calculator. You know, like this is the solar panel in the calculator. So this panel is responsible for trapping the energy and converting the solar energy into electrical energy. Right. Okay. Now let's talk about biomass. Okay, let me check the chat window. It does not have solar panel. Instead, we can. What if it rains on the solar panel? Will it break? No, no, the rain won't break the solar panel, but you know, when you have rain, usually you don't have the sun. When you have rain, I mean, you have clouds, and that means, you know, the solar rays, the sun rays are blocked. Solar panel is a panel designed to absorb the sun rays as a source of energy for generating electricity or heat. It is surrounded by a teacher. What if? Our solar panel important? What is biomass? Okay, so so tell me something. Okay, for each type of energy that we are going to discuss, I will ask you what category of energy or what type of energy does this fall into? The types of energy that we have discussed. Remember in the last two classes, the type of energy: kinetic, potential, or you know, magnetic, sound, electrical, nuclear. So what do you think? What is this solar energy? What type of energy is solar energy? Tell me, Sidra wants to answer. Potential energy? No. No. Aisha, nuclear? Well, you're close. Nuclear is converted into? Yes, yes, you're correct. Sundus, you are correct. Sundus said electromagnetic radiation. Yes. So solar energy is actually electromagnetic radiation. I just mentioned nuclear energy is for as long as you know, inside the sun. But when it has to travel through the vacuum, it has been converted into electromagnetic radiation before it hits the surface of the earth. You understand that? Okay, so yeah, it's electromagnetic. Okay, that's why it can pass through the vacuum, right? Okay, let's talk. So after every type of energy, I will ask you what is the type it is. I mean, what type does it fall into? And secondly, what is the source? Source, what is the source of? A source is easy, source is the sun, right? Can solar panels store energy? I think it can convert. I don't think it can store. Yeah, maybe, but they are working on storing it. But I'm not sure. Maybe they are working on storing it. Yeah, we do have, you know, solar panels that trap energy, especially on the street lights that are recently installed in Pakistan. Yeah, and so, you know, the whole day when it's sunny, the solar panels are trapping and storing. And then at night, when there is no sun, that stored energy is used to light the bulbs, right? So maybe, yeah, there is a facility of storing. Okay. Biomass. Okay, talk about biomass. Let's talk about biomass. Now, biomass, as the name suggests, biological mass, okay? Some mass that is coming from biological sources. What do we mean by biological sources? Bio means life, again, living materials. So now, all the living materials have energy stored in them. And what is that type of energy? Which is stored within chemicals, remember? What is that type of energy which is stored within chemicals? Any chemical, be it living, non-living, whatever. Yes, yes, Aisha, chemical, but give me a complete name. Very good. Yes, Sidra. Yes, Iman Javed. Yes, chemical potential energy. Good job, Iman Javed, Javeria, Amra Javed. Very good. So yes, so the energy stored within the chemicals which are making these living materials will be an example of chemical potential energy. And that happens when there is photosynthesis going on, because if you trace back the sources of energy, or most of the energies source will end up at sun. Okay, sun is the primary source of all other types of energy, most of them, okay, except for a few exceptions. most of the types of energies are originating from the sun. Okay, so again, here the energy, which is chemical potential energy in the living materials and plants, are also originating from the sun. Why? Because it was photosynthesis. Remember, it was photosynthesis that trapped, remember, the chlorophyll trapped the energy from the sun rays, and then it was converted into glucose. Glucose was what was being made, right, in the plants. And so when the animals ate those plants, that energy got converted in, I mean, that energy got transferred into the plant, into the animals. And then when we ate the animals, that energy got transferred into us, right? So our body carries part of that energy. Animals' bodies carries part of that energy. Plants carry that energy, right? Why do we eat vegetables? Why do we eat vegetables or fruits? Because they have the same chemical potential energy. Remember this diagram that I explained, how the energy is, you know, transferred to that cup of orange juice I discussed in my last class. So yeah, everything, every living thing has energy, and you can trace that energy back to sun. Right, now that energy, which is stored in the bodies of living materials, can be released when that material is either eaten or burned, or if it undergoes bacterial decomposition. Okay, like why do we eat? Because that energy is released into our body when our body digests it, right? And when we burn woods, that energy is released in the form of heat, fire and heat. Yes, that energy is converted into light and sound and heat and thermal energy and all of that. So biomass is when we use those living materials as a source of energy. And we use the process bacterial decomposition. Okay, we use the process bacterial decomposition. So we can call it biofuel. Okay, and we use a container. It's called a biodigester, and I will show you a picture of biodigester in a moment. And so all the rotten living material, such as the leftovers, vegetables, fruits, woods, yeah, and dead animals or plants, and even the cow dung or the excreta of the animals. All these are living material, and they have chemical potential energy, which we make use of. How? By putting them in a container, which is called a biodigester, and we heat, in a warm place. It should be in a warm place, so as to encourage this process of decomposition, bacterial decomposition. What is bacterial decomposition? Decomposition means to break down into simpler substances, to break down into simpler components by the bacteria. Okay, and when it is done by bacteria are small single cell organisms, right? And so when they do this, when this process takes place, energy is released. Okay, because this is a process which releases energy. First of all, gas is released. That gas is called a biogas. That's called a biogas, and that gas is basically methane. You don't have to go into the details of this if you don't understand this, but methane is a name of that gas which we use for cooking. The gas that we use for cooking in the gas cylinders. Many of you might be using gas cylinders in the kitchen, and in Pakistan we have those gas stoves. That gas is methane. Okay, it's made up of hydrogen and carbon. It's a hydrocarbon made up of hydrogen and carbon. Now that gas is very good for releasing energy, and that is why it is used for cooking, because when it burns, it releases a lot of energy, and that energy is what cooks the food, right? So this methane is also called biogas when it is released by food or by the organic material which is going bad or which is rotting away due to bacterial decomposition within a biodigester. So scientists and people have come up with the idea that instead of this rubbish or this decomposing matter creating havoc in our environment and creating pollution in our environment, why don't we use it in a constructive way? Why don't we put this in a container under the ground, and we can use this energy in a positive way? you know, because otherwise it would be dumped here and there, and it is a hazard for health, and it is unpleasant and everything. So why don't we use this in a constructive way? So the gas which is produced is used for different purposes. Now let me show you a picture. Okay. This is a picture of, yeah, this is a picture. So can you see, this is a container that they have kept underground. Okay, and there's this brown color thing is the organic, the rotting away organic material. And these blue arrows are showing the gas being produced, which is methane or the biogas. And then they have made these pipes which will allow this biogas to be used for different purposes, okay? And can you see they have obtained this excreta. They have connected this container via pipes to the lavatory and to the excreta of the cow and the other cattle animals. And then they have other pipes which are taking the gas which is being produced into the house, into the kitchen for cooking, okay, or for other purposes, okay. It is better than letting it pollute our environment, and also it is better than cutting the trees. It is better than cutting the trees or by burning the woods, which will also cause pollution, right? So again, the problem with this again is that this is not that as efficient as burning oil. Burning oil would give us more energy. Okay, now in your book they have also mentioned that in Brazil sugar cane is grown and they get sugar out of it. That sugar is converted into alcohol, and then they use this alcohol instead of petrol. Now again, this alcohol is not as efficient as petrol is. So, you know, like this is not a long-term replacement. No, methane is not a deadly gas. I mean, you have to use it in a controlled manner. I mean, of course, if you have accumulation of methane and you don't have ventilation, of course, it's lethal. But if you use it in a proper way, appropriate way, no, I mean, you can use it. Okay. So this was all about the biogas. Now let's talk about the wind. And so tell me, what is the type of energy here? So we already discussed, it's chemical potential energy, right? It's a type of chemical potential energy. And what is the source? What is the ultimate source? Where is it coming from eventually? Fossil fuel? No, fossil fuels are organic matter that are being pressurized and heated for millions and millions of years. Now this is not, now please don't confuse this with fossil fuel, okay? Now the process in case of biomass and fossil fuel is the same. I admit the process is the same, but the duration and the sources are different, and that makes a lot of difference. Fossil fuels undergo fossilization over millions and millions of years, and that is happening naturally, okay? Whereas this is being done artificially, and this is short time duration, okay? Gas in both the case is the same. The natural gas which is produced from fossil fuels is also methane, and this is also methane. Gases are the same, but the sources are different. This is renewable, that is non-renewable, okay? Okay, so let me check the chat windows if there are any good questions for me to answer. Manal Ahmad, very good. Good job. Sun is the original source, right? Yes. Because remember, photosynthesis is what trapped the chemical potential energy, and that came from the sunlight. Photosynthesis requires sunlight. So the ultimate source of energy for biomass is also sun, okay? Okay, what is joules? I never talked about joules right now. Joules is a unit of energy. What if there is no solar panel and you're still getting energy? Where would the energy be coming from? Sun, the source is plants and animals. Yeah, Mariam Afzal, source is plants and animals, but I said eventual, you know, like the ultimate source. I mean, where did the energy come from in the plants and animals? From the sun, right? So sun is the I did not understand bacterial decomposition. Decomposition just means breakdown into simpler substances, and when that is done by bacteria, bacteria are single cell microscopic organisms. So yeah, okay. Let's talk about wind energy. Okay. Yes, biofuel and biomass are the same. Biofuel is a term when that mass is being used as a source of energy. When that mass is used as a source of energy, it's called biofuel. Okay, wind energy. Now, this is easy to understand. Wind energy is, you know, when the wind blows, and when the wind blows, it moves the windmills or the wind turbines. Okay, and when the wind turbines or the windmills move, that kinetic, you know, movement of the turbines is kinetic energy. Remember, kinetic energy is the energy of motion that is converted into electrical energy, right? But again, the problem is that it's not as efficient as the oil. Okay, why? Because 2,000 very large wind turbines will produce enough energy which is generated by one modern power station, and that too when there's lots and lots of winds, and the wind does not blow every day, and you cannot, I mean, it's not as predictable if the day is going to be windy or not. So those are all the drawbacks. Okay, so this energy is not available all the time. Okay, so let me show you windmills and wind turbines. Now, what's the difference between windmill and wind turbine? Windmills have been used for centuries and centuries. You know, like this is a windmill. This is a windmill. Okay, and when the wind moves these mills, these panes of the mill, this kinetic energy is then used to grind grains. Okay, to grind grains in flour mills. Okay, in olden days. Now this is turbine. This is a turbine. So this is the modern turbine. We use this. Okay, and so again, the phenomenon is the same, that when these panes move, kinetic energy is converted into electrical energy. And so we have to have lots and lots of them. I don't have a picture of a lot of windmills. So we have to have lots and lots of them, you know, like 2,000 at least, to be able to produce as much energy as is produced by one modern power station. And that requires a lot of land space, and you know, it also affects the beauty of the natural beauty of that area. Okay, let's talk. So what type does this? Very good, Mariam Afzal, very good. So Mariam, can you please also explain us, why did you say that the ultimate source of wind energy is the sun? How come? How come? What is the ultimate source of energy of wind? You said sun, that is correct, but explain me how. A windmill generates mechanical energy from wind power, while a wind turbine generates electricity from wind power. Fatima Mohsen, you're copy pasting from Google, but it's okay. That's fine. Yes, your answer is correct. So what do you understand by mechanical energy, Fatima? What is mechanical energy? Yes, Sidra? What was mechanical energy?
Mechanical energy is the combination of kinetic and potential energy.
Very good job. Good job. It is the sun, because the sun heats up the air. So heating up the air is what blows it. Is heating up of the air is what, you know, makes the turbines rotate. Can you explain a little more in detail? Okay, Momina, I will unmute you. Momina. Yes?
Can you repeat the question once again?
I can't hear you. Can you please speak a bit louder?
Can you repeat the question once again?
For some reason, I cannot hear you. What went wrong? Can you speak again?
Can you repeat the question?
Okay, my question is that Mariam just said that wind energy's ultimate source is sun. So I'm asking how.
When sun heats up the air on Earth, it moves due to convectional currents. Convectional currents is that the warm air takes place of the cold air and the cold air takes place of the warm air. That's why that movement we feel as wind.
Very good. Yes, yes, yes. That is correct. Also, I would like to, okay, Jazakallah khairan. You can mute yourself. Also, I would like to add is that, yes, you are right. So when the warm air rises, there is less pressure. And so where you have cold air, there is more pressure. And remember, wind blows from a region of high pressure to low pressure. Okay, if you did not understand what is pressure and what is this and that, don't confuse yourself. We will talk about this in detail later. Okay, but yes, for now, if you know what a convection current is, do you know what a convection current is, Sidra? You don't know? Okay. So, okay, so for those of you who have not done convection current, this explanation I think would suffice that, you know, when the warm air is heated up by the sun, it rises, and because it is rising, there are less molecules, and so there is less pressure, okay? And where the air is cooler, there, you know, it contracts, or, you know, it contracts and the air molecules come together, and so the air gets denser and therefore heavier, and so it sinks. Okay, so this sink, and so the air blows from where it is lighter to where it is, no, sorry, the air blows from a region of high pressure to a region of low pressure. Okay, from the cold to the hot area, like that. Okay. Now, wave energy. Now, again, this is easy to understand. So what was the type? What was the type? So we did the source. What was the type? I'm sorry. Yes.
Kinetic energy.
Right, kinetic energy, because we are dealing with the movement of the wind molecules, right? Very good, Mariam, it's kinetic, right? Wave energy, the wave energy. Again, now what are these waves and why are they produced? Due to the wind blowing over the surface of the sea. So when the wind blows over the surface of the sea, you have these you have this water mass being disturbed and being blown into waves, right? So this, again, what type of energy will this? Kinetic, right? Right. And so, but how is this done? Let me share my screen again with you guys. Let me, okay. So these are called floats. These are called floats. Look at this. You know, these are devices like this, which are left in the sea, okay? And as the waves move this float moves, and that kinetic energy is converted into electrical energy. So knowing this much is enough. You don't have to go into the details of how, you know, this is done. But can you see there are lots and lots of floats in this picture? You can see lots and lots of floats being distributed on the surface of the sea, and as there are waves, the floats are moving, and the movement of float is kinetic energy, which is getting converted into electrical energy. Okay, so that's that. So again, the problem with this wind wave energy is that it is not energy efficient. It is not energy dense. Who is this co-admin security? But there are two of them. Maybe it's you. Okay, so wave energy. So again, it is not energy efficient and it is not energy dense. And so you need at least 20 kilometers of floats to generate as much power as a single modern power station. Again, the same problem. Can you see? No source of energy has been as efficient as our fossil fuels. That is why fossil fuels are still in demand. Okay, we cannot live without fossil fuels. Now, tidal energy. Let's talk about tidal energy. So right now we just talked about wave energy, and now this is tidal energy. What's the difference between the two? Beta zoor se. Yes. No.
Wave,
Yes.
wave energy is calmer than tidal energy. Like tidal energy has more force.
No.
That's what you're saying.
No. No. That's not the difference. That's not the difference. So who will tell me? Is there any difference between wave energy and tidal energy? And what's the difference? Wave is due to wind and tidal is due to the moon. Very good, Aisha. Very good. Waves are made by the sun and tidal is by the moon. No, Manal. No, no. Yes, Aisha is correct. Okay, so let me talk about the tidal energy. Now, this tidal energy is the energy due to difference in the tides of water. Okay, what are tides? What are tides? Yes, Aisha, you are correct. It is due to the moon. Well, it is also due to the sun, but primarily it is due to the moon, right? Now, it is due to the attraction between the moon and the earth. Okay, remember, you may not have done this before, but any two bodies that have mass, they tend to pull each other. They tend to attract each other. And that pull, that attraction is called the gravitational pull. So gravity is not only between the earth and us and the objects on it, but gravity is between any two objects. Okay? So it is due to the attractive pull exerted by the moon on the earth that the water is pulled towards the moon. The water is pulled towards the moon. And that causes the level of the rivers and the level of the oceans and the seas to rise. Now, due to the rotation of the earth and the revolution of the moon, the position of the earth relative to the moon keeps changing, and so we keep having high tides and low tides. So sometimes the earth is closer to the moon, where in which case there will be high tide, and in other cases the earth would go away from the moon, and so the tide would be low. Right now, when there is high tide, we build barrages and dams to contain that water. And when there is low tide, the water falls back. The water moves back to its original position. Now, when the water is falling back, we have put turbines in the way. So when the water falls, it will move the turbine, and that movement will be kinetic energy, and that kinetic energy can be converted into electricity. So that's the basic idea behind this tidal energy, and I will show you a little video and a little picture. Okay, so okay, if you did not understand, watch this, and then again I will try to explain you again if you did not understand. Okay. Okay. So, like for example, this is a river, and can you see a small stream coming out of the river? Now, I wouldn't call that a stream. That's called an estuary. It's called an estuary. Okay, estuary, you can call it, like an extension of the river, a sideways extension of the river. Now, when the tide is high, meaning that the moon is closer to the earth because of, the rotation and the revolution of the moon, and the revolution of the earth as well around the sun, because of all these movements, there are moments when earth and moon come closer together. And when that happens, the attractive pull increases. And that increase in the attractive pull causes the water level to rise. Now, when the position of the earth is such that the earth moves away, or that particular part of the earth moves away from the moon, the tide is low because the attractive pull is low. Now, when the water is moving from high tide to low tide, it's like sort of falling. And so, what they do is that they make a dam across the opening of this estuary. So when there is low tide from high tide, when the tide is changing from high to low, the water will move back. So when there is high tide, the water will get into the estuary from the river, right? And when it is low tide, the water will flow back from the estuary back to the main river. Right now, when it is falling back from the estuary into the main river, in the course, it will move the turbines because they have installed turbines at the mouth of estuary. Mouth is where the estuary is coming out of the river, right? Okay. So when the turbines move, that is kinetic energy. That kinetic energy is converted into electrical energy. I hope I made sense. So this is a dam. Okay, but let me show you tidal power. Now I'm running this little video just to give you an idea. Okay. No, so now you can see the turbine, which is moving inside the water. Now, because of the rotation of the moon and the earth, there are positions when the earth is closer to the moon and the moon is closer to the earth. Okay, so this is low tide, and in high tide, the level of the water rises, right? Now, when the tide would move back from high to low, it would fall. And when it will fall, it will move the turbine. Now they have tide, yeah. So as you can see, the high tide would now fall to a lower level. And when it is falling into the lower level, the water is making the turbines move. And when the turbines move, that is converted into electrical energy. Okay. So I hope you understood that bit. So that is all which is important for you to understand. This is another video I found useful. Let me share with you. Okay. Now this is low tide, and can you see high tide? Can you see the water level rising? And this is not due to rainfall or anything. This is due to tide. Can you see the water level rising? Yeah, this is high tide. And now again, this is low tide. Okay. Now, when this level change occurs, that's when the water falls, and that's when you make the turbines move. Okay, and this is due to gravity, which is the attractive pull. Now, this is the earth, and that is the water, layer of water on the earth. Right, now the moon will attract the earth and the water. Right, now you can see the water being pulled towards the moon, so this is high tide. You can see the water being attracted towards the moon, so that's high tide. Okay? So that's what we mean when we say high tide. Okay, so that is low tide on the other side of the earth because it has gone farther away from the moon. So the parts which are closer to the moon will experience high tide, and the parts which are farther away from the moon will experience low tide. Okay, so that's it. I can forward these videos if you're interested. Okay, so I hope you understood the tide thing. Okay, so tell me now, what type of energy is this? And what type of energy is this? Where is my screen? What type of energy is this? Yeah, sure, I'll share these videos in the group. Okay. Yes, very good, Javeria. It is kinetic energy. Ah, Iman Asim, you said gravitational potential energy. Can we think of it that way? That's a very good, yeah, gravitational potential energy getting converted into kinetic maybe. Yeah, so yeah, that's good. I see, I did not think that way. But, you know, when you teach a group of people, you have different ideas pouring in. So, and that's good. Okay. So yeah, you can call it gravitational potential energy getting converted into kinetic. Okay, so what's the source? What's the source? Very good, Javeria. The original source is moon and to some extent sun. Now, remember, gravity is the more the mass. The more the mass, the more the gravity. So thinking that way, sun is many times bigger than the moon. So sun's gravity should be way higher than that of moon. But it is the moon which is causing these tides. Why not the sun? Why not the sun? But sun is so much bigger than the moon. Very good, Sidra. Say it loudly.
The Earth is not close enough to the sun.
Right, because the sun is so far away. Moon is closer. Okay, but sun does exert some attractive pull, but moon's gravitational pull is stronger. Yes, Javeria, because the moon is closer. Right, very good. Yes, Muhammad Rayan, because the Earth is far away. Now, let's talk about the geothermal energy. Now, geothermal energy, as the name suggests, geo from the earth, thermal, heat. Okay, so heat inside the earth. Now, where did the heat where did the heat from inside the earth come from? Why? So what's happening in the core? Very good. Hamid Azam, you said core. So what's happening in the core? So what's happening? Reactions. Hassan Nadeem, very good. With what sort of reaction? Are you reading from here? Yes, okay, because of the magma in the core. So what's happening? Yes, so there's radioactivity going on. Yes, Javeria, I hope you did not read. Yeah, I'm just kidding. Okay, so yeah, there's radioactivity going on of the mineral ion, the minerals that are there inside the earth. And radioactivity is what? What is radioactivity? Again, the same nuclear energy. Again, the same thing. You know, the subatomic particles are being released from the nuclei, and when they are being released, and they're being released gradually. Radioactivity is when nuclear energy is released gradually. It can be harmful, it can be useful. Okay, depending upon how we use it, and depending upon the amount of energy within it. So that radioactivity is going on inside the earth, which is warming the inside of the earth, and therefore the water, the underground water, because of this energy, gets warmed up or is hot. Now, where this water, now of course, hot water is in the form of vapors or steam, right? Or even if it is in the liquid form, it is still energetic, it is warm. Now, and water tries to find its way out. So where you have cracks or fissures and there is some opening to the surface of the earth, that's where the water gushes out to the surface. The water comes to the surface, okay, with a lot of force, okay? And I'll just show you. There are geysers and, you can see steam coming out from under the ground. And this energy can be converted again into electricity, and that's what we call geothermal energy, okay? Now, let me show you real quick because we are running out of time. Let me show you. Okay. A geothermal energy. I'll show you. This is another video I'm sharing with you. So can you see this is geyser? This is a lot of steam coming out, a lot of steam gushing out of the ground. All these are geysers. All these are geysers. So this energy is being used to generate electricity. Now, how this steam is made to pass through pipes, and that pipe will take this steam to the turbines. Okay, now this is hot water deep inside the earth, and can you see the cracks and fissures that is giving the hot water steam way to come on the surface? Can you see that? So now they will show you a geothermal power plant. Okay. Now the steam is made to pass through pipes. Okay, and those pipes will take the steam over the turbines. Again, the turbines will move, converting kinetic energy into electrical energy. And what they also do is that they introduce water. They inject the water underground so that it can be warmed up, and then they let it come out from some other spot, and so they do it artificially as well. Okay, let me just show you. Yeah, can you see the red pipe? The red pipe is the warm water coming out, and they are introducing the cold water, the blue pipe. The blue pipe is being taken underground, and it is heating it up. The hot water is coming out, and then now the steam will move over the turbine. Can you see the steam moving over the turbine? Yeah, the turbine moved, and then that energy is getting converted into electrical energy. So that's it. So that's it. Okay. So it's 8:10, so the time for my class is over. But anyway, I'm just left with this last. Yeah, so what is the ultimate source of energy? Good job. What is the ultimate source of energy for geothermal? Is it sun this time? Say it loudly. Earth. Yes, earth.
The heat under the earth.
Right. It's the earth, and it's radioactivity. Yeah, it's radioactivity. So Mariam Afzal, I wouldn't call it kinetic energy. It's, I think, radioactivity. And so radioactivity is different from kinetic energy. Kinetic energy is the vibration of the whole particle, whereas electromagnetic radiation is due to the jumping of electrons between the energy levels within the atom, remember? So yeah, so it's the it's the radiation getting converted into thermal, right? So it's radiation, yeah, electromagnetic getting converted into thermal. Good job. And the ultimate source is the earth. Okay, so okay, now hydroelectric, real quick, this is easy. Okay, we are out of time. Hydroelectric, as the name suggests, so at mountainous areas where the height is more, okay, if we have rainfall, and you know, usually the rainfall is more at higher elevations, higher altitudes, and so the water accumulates, okay. And so when that water is allowed to fall from a higher height to a lower level, when that water falls, it again moves the turbines, and that is kinetic energy, which is converted into electrical energy, right? So what is the type ultimate, what is the first of all type of energy? Hydroelectric. Kinetic, because it is the movement of water molecules. Okay. Kinetic, but Manal, not electromagnetic. No, this hydroelectric is not electromagnetic, it's kinetic. Yes, yes, Abu Bakr, yes, Abdullah Musabbar. Kinetic, Mariam Afzal. Okay, so what is the source, ultimate source? Sun, very good. And what causes rain? What causes rain, right? Yeah, rain is due to the water cycle, and water cycle is due to the sun. Sun is the ultimate driving force behind the water cycle, right? Okay. So in the next class, we will do the questions related to it, okay? And let me just show you real quick the diagram of, yeah, you can leave. Whoever wants to leave can leave. These are voluntary classes, okay? So I want students who are interested themselves, not because you are forced to, but because you want to. Okay, so this is a diagram that I wanted to share with you, okay, of a hydroelectric power dam. It's an hydroelectric dam. So you can see that the water level on the left side, the level is higher, okay, and that's a reservoir. So when the level of river when the level of water in the river is higher, the water is stored in the reservoir, okay, and when the level of water in the river falls down, the water falls back through this penstock back into the river, and you know, in falling back, it moves the turbines again, producing electrical energy, right? Okay. Okay, so we will do the end of chapter, or sorry, the further questions regarding this chapter in our next class, okay? If there are any questions, please ask. Otherwise, I will end the meeting. What is dam stick? I did not talk about any dam stick. Steam lets the turbine move automatically. No, steam has power. I mean, steam has energy. It has kinetic energy. And so, you know, it like pushes on the turbines. What do you mean automatically? Nothing is automatic in this world. Okay, kinetic as the molecules of the water are moving. Right, right. Yes, Atika, you are correct. Okay, okay. Assalamu alaikum wa rahmatullahi wa barakatuh.